Hello, welcome to this education tutorial titled An Introduction to Postcoordination. My name is Linda Bird. I am the Implementation Support Lead at Snomed International, and I'll be presenting this tutorial together with Anna Højen, who is an Education and Product Support Specialist, and Kewley, who is a Technical Architect, both at Snomed International. In this tutorial, I'm going to start by explaining what postcoordination is and when you should use it. And then Anna's going to take over to look at the different tasks of a health record and explore how postcoordination can be used in each of those. Anna will answer the questions, how are expressions created, stored, displayed, and exchanged? And then she'll pass back to me to explore the question, how are expressions queried? Kai will give us a short demonstration of some of the steps that are required, and then we'll conclude the tutorial by summarizing what you need to implement postcoordination. So let's get started with the question, what is postcoordination? But before we answer that question, let's explore some important facts about Nomencity concepts. A concept is a clinical idea with a unique Snomed identifier that's distributed as part of a Nomencity release. Concepts are linked to terms by descriptions, which provide a human readable representation of the meaning of the concept, and they're related to one another by defining relationships. These defining relationships provide a machine processable representation of the concept's meaning. So, as an example, here is a view taken from the Snomed International Nomencity browser, which shows the details of the disorder concept fracture of tibia. This concept represents a clinical meaning that's uniquely identified by the concept ID 3197802. It has two descriptions. The fully specified name is fracture of tibia disorder, and there is one synonym, which is the preferred term in US English, fracture of tibia. It has four relationships, which together fully define the meaning of the concept, and they are fracture of tibia is an injury of tibia, it is a fracture of lower leg, it has a finding site of bone structure of tibia, and an associated morphology of fracture. A Nomencity expression is a structured combination of one or more concept identifiers used to represent a clinical meaning. So expressions provide an extensible approach to representing clinical meanings because they allow new meanings to be represented that haven't been predefined in a formal Nomencity release. There are two main types of expressions. The first is called a pre-coordinated expression, and these expressions contain a single concept identifier and optionally one of the terms associated with the concept to make the expression human readable. For example, a pre-coordinated expression, which means fracture of tibia, can be represented as 3197802, optionally followed by the term fracture of tibia placed in vertical bars known as pipes. The second type of expression is called a post-coordinated expression, and these normally contain two or more concept identifiers. An example of a typical post-coordinated expression for fracture of the left tibia can be read as fracture of the tibia with a laterality of left. And lastly, compositional grammar is the syntax used to represent Nomencity expressions. Compositional grammar is a formal grammar described using a notation called ABNF, which stands for Augmentus Backus-Naur form. This basically describes what symbols you can use and how the parts of an expression can be constructed and then parsed. The compositional grammar syntax is defined in a specification that you can find at snomed.org/SCG, which stands for Snomed Compositional Grammar. Here is an example of a compositional grammar expression that represents an open fracture of the tibia. The expression can be read as fracture of bone with an associated morphology of fracture open and finding site of bone structure of tibia. In this expression, the focus concept is the fracture of bone, while everything after the colon is the refinement. And this refinement includes a role group, shown with the curly braces, and two attributes, each with an attribute name and an attribute value. There are two main techniques you can use in your post-coordinate expressions. First, a Nomencity post-coordinate expression may refine the meaning of a concept by applying a more specific value to one or more of its defining relationships. For example, the concept fracture of tibia has the defining relationship associated morphology equals fracture. By specializing the associated morphology from fracture to open fracture, we can represent the clinical meaning open fracture of tibia using the post-coordinated expression fracture of tibia with associated morphology equal to fracture open. Another technique is to refine the meaning of a concept by applying additional attributes that are permitted by the Nomencity concept model. For example, because fracture of tibia is a subtype of clinical finding, the concept model allows us to use the due to attribute. We can therefore represent the clinical meaning fracture of tibia due to fall on ice using the post-coordinated expression fracture of tibia with due to equal to fall on ice. And once again, we can omit the human readable terms if we need to shorten the expression. The Nomencity concept model specifies the rules for how Snomed content can be defined, including the domain, range, and cardinality of each attribute. For example, the domain of the finding site attribute is all the clinical findings, and the range is the set of anatomical or acquired body structures. So this relationship, fracture of bone, has finding site bone structure, is concept model valid because the source concept, fracture of bone, is a type of clinical finding and is therefore in the valid domain of the attribute, and the destination concept, bone structure, is a type of anatomical structure, so it's in the valid range of the attribute. There are well over 100 attributes in Snomed's concept model that can be used to define the meaning of clinical concepts, and each of these attributes has concept model rules associated with them. Here is just some of the hundreds of attributes used in Snomed. For example, after, before, finding site, finding context, has active ingredient, procedure device, route of administration, and surgical approach, but there are many more. And each of these attributes is designed to be used only in specific domains. A concept model domain is the set of concepts which can have defining attributes applied. Most domains are defined based on a specific hierarchy, like clinical finding or procedure. This is the list of hierarchies which currently use defining relationships. The only other domain that's not listed here is the lateralizable body structure domain, because this is the only one that's defined using a reference set. In the case of laterality, even though laterality can be applied to any body structure, it's recommended that you only apply laterality to members of the lateralizable body structure reference set, which contains body structures that can have a left one and a right one, like the kidney structure, where you can have a left kidney and a right kidney. And for each of these domains, there is a limited set of attributes that can be used to define its concepts. For example, subtypes of clinical finding can be defined using these attributes and a number of others that are defined in the concept model. You'll notice that the concept model also indicates whether or not an attribute should be placed in a role group and the cardinality of each attribute. Actually, there are two types of cardinality. The first one is the attribute cardinality, and that represents the number of times the attribute can appear anywhere in a concept definition. In most cases, this is 0 to many times. And the in-group cardinality is the number of times the attribute can appear within a single role group. and in most cases the in-group cardinality is 0 to 1. Each attribute in the concept model also has a limited set of values that can be used, and this is called the range of the attribute. Both attribute domains and ranges are defined using a Snomed language called the Expression Constraint Language, or ECL. But as an example, the value of the after attribute must be a descendant or self of event, or a descendant or self of clinical finding, or a descendant or self of procedure. It's really important to understand the Snomed concept model so that when you're creating an expression, you do so in a way that conforms to the concept model rules. And the reason why this is so important is that in order to be able to query post-coordinated expressions, you need to be able to classify them using a description logic reasoner. This is the process that automatically compares each expression with each of the concepts in Snomed to determine where the expression sits in the hierarchy, what it's a subtype of, what inferences can be made. And it's this process that makes expressions queryable. I'll explain all of this later in the tutorial. So by using the concept model, we can ensure that the formal meaning of an expression is captured in a consistent and machine processable way. And this is where the MRCM comes in, the machine readable concept model. This represents the rules from Snomed's concept model, the domains, the ranges, the cardinalities, etc., in a formal machine readable way. The MRCM is published and versioned with each international Snomed release. And the MRCM concept model rules for pre-coordinated content, which our Snomed authors use, is automatically populated into these tables in the editorial guide at snomed.org/eg. However, if you're creating post-coordinated expressions, you need to look at the full concept model, and that's available through the MRCM browser in the Nomencity browser. So to find it, you can go to snomed.org/browser, and there you'll see a link to the MRCM browser. You can also find the MRCM specification at snomed.org/MRCM, but it's the browser you'll need to go to see the concept model rules. Next column, all of the valid attributes that can be applied to that domain. And we're going to select the finding site attribute for our expression. So the next question is, what are the valid values for this attribute? And once again, we can look at the MRCM browser and see that the valid values are the descendants and self of anatomical or acquired body structure. So we can select a concept in this range, such as gallbladder structure. And we now have a concept model valid post-coordinated expression, cancer with finding site of gallbladder. Now, when you're using the MRCM browser, it's important to remember that you're looking for the rules with a mandatory strength, and the content type needs to be either all Snomed content or all post-coordinated Snomed content. And that will give you the MRCM rules that particularly apply to expressions. So the next question we're going to discuss is, when should I use post-coordination? Well, there are a range of use cases in which it may be useful to use post-coordination. For example, post-coordinated expressions can be used to capture new clinical meanings in a health record that can't be represented using a pre-coordinated concept. They can be used to share clinical data between systems, for example, in an HL7 message or a FHIR resource, and to enable interoperability between different structural representations of the same clinical meaning. They can be used to map from other code systems or from interface terms to Nomencity to capture an equivalent representation of the meaning. Post-coordinated expressions can be used by natural language processing tools to represent the coded meaning of free text when there is a specific context or a greater amount of detail in the free text than you can capture in a single pre-coordinated code. And Snomed expressions can also be used to represent the definition of a pre-coordinated concept. If you have a look at the Nomencity browser at browser.ihsstotools.org, you can take a look at the tab titled Expression, and you'll see near the bottom the inferred concept definition represented as a post-coordinated expression. But for most of these, it's normally sufficient, and no pun intended, to use published concept identifiers to support the use cases. And before you launch into a post-coordinated solution for these use cases, I think it's important to understand that in some cases, there are alternatives to post-coordination that may be easier to implement. The two main alternatives to post-coordination are, firstly, and perhaps the most obvious alternative, is to add the new clinical meaning to an extension as a pre-coordinated concept. This allows you to use the standard Snomed authoring tools to classify the concepts and distribute them in a way that supports queries. However, this is an alternative that's just not an option for everyone, and it also does require maintenance of the content and a formal release process, etc. The second alternative is to define the post-coordinated structure using the information model, with separate coded data elements for the focus concept and each of the refinement values in the expression. So, for example, rather than using an expression for fracture of the foot, we could use two separate data elements, one to record the Snomed concept for fracture and the other to record the Snomed concept for foot. So then, in what situations can you use post-coordination? Well, if you need to be able to represent new clinical meanings which can't be represented using existing published Snomed concepts in your information model, it may not be possible to use one of the alternative approaches. For example, you may not be able to change your information model, or you may decide that using multiple fields may be too time-consuming for data entry. And you may decide that the overhead of creating and maintaining an extension is prohibitive, or you may need to create a new clinical meaning dynamically, for example, if you're developing a natural language processing tool. So if you need to be able to represent new clinical meanings without being dependent on specific pre-coordinated concepts existing or changing your information structures, then post-coordination may be an option to consider. However, you can only use post-coordination if the clinical meaning that you need to represent can be represented in a consistent manner using the Snomed concept model. And we briefly talked about why this is so important, but we'll discuss this again when we look at querying expressions. But for now, it's important to keep in mind that not all clinical meanings can be fully represented using the Snomed concept model. So post-coordination can only be used for clinical meanings that fall within the scope of the Snomed concept model. And thirdly, you should not attempt to use post-coordination unless you have a good understanding of what tooling is required to implement post-coordination safely, and unless you actually have that tooling. To use post-coordination, you need tools available that support the correct processing of expressions. And once again, we'll talk more about this later in the tutorial. So, with those cautions in mind, let's assume that we've decided that it is appropriate to use post-coordination in our electronic health record solution. There is no suitable alternative, and the clinical meanings that we need to represent fall within the scope of the Snomed concept model. We're going to start with a terminology repository containing a published Nomencity edition and an expression repository to hold our post-coordinated expressions. And to simplify the implementation of these, we're going to make them available to the EHR via an application programming interface or API. So we're now going to look at how we can use expressions for data entry, display, exchange, and querying within an EHR system. And Anna is going to walk us through the first three of these topics. Over to you, Anna.
Thank you, Linda. So now that you have been introduced to Nomencity expressions and when they should be used, I would like to continue this tutorial with explaining how clinical data may be captured, stored, and displayed using postcoordination. There are three main approaches to entering postcoordinated clinical data into an electronic health record. You can use pre-populated lists. You may use a form-based approach, or you can use free text with natural language processing to encode the free text with Nomencity. And let us now explore each of these approaches in more detail. When using pre-populated lists, the user is presented with a list of clinical phrases, which we call the interface terms, using a pick list, checkboxes, or another type of data entry control. But essentially, what the user sees is a list of clinical phrases that each represent some clinical meaning. Like in this example, the user interface might include a list of phrases such as open fracture of left radius and open fracture of right radius. Behind the scenes, some of these phrases may be linked to pre-coordinated content, while other phrases may be linked to post-coordinated expressions. Here the phrase open fracture of left radius is associated with the expression open fracture of radius with a laterality of left. And the phrase open fracture of right ulna is associated with the expression open fracture of ulna with a laterality of right. This approach requires the expressions to be created and linked to an interface term by a Nomencity implementer, as part of the terminology binding process in the design stage of the implementation. The second approach is the form-based approach, where the combination of values recorded in different data entry controls results in specific expressions to be formed. In this small example, the value of the diagnosis field and the value of the side field are used to represent different parts of the resulting expression. And as shown here, this approach uses an expression template to ensure that the selected values are added in the appropriate places within the expression. If, for example, a user enters the values open fracture of radius as the diagnosis and the value left in the side field, the values entered are then used to populate the slots in the expression template and form an expression representing the meaning of an open fracture of radius with a laterality of left. These expression templates should be created during the design phase of the implementation and are then populated with values at runtime when the user selects values in each field. The last approach to mention here is using a free text approach, where the clinical user enters the information in a dedicated text box using the terms of his or her own choice. The text is then analyzed by a natural language processing tool to codify the key terms as Nomencity concepts, with the machine-readable concept model helping to identify the relationships between these key terms to form Nomencity expressions. So in this approach, the expressions are usually created at runtime as the user types in the free text. So this requires the system to incorporate a Nomencity-enabled natural language processing service that works in the local dialect. Once you have used one of these three approaches to capture the post-coordinated clinical meanings, You then need to store your expressions in your electronic health record data store. So I will now talk about how this is done for each of these approaches. So back to the first approach of using pre-populated lists. In this approach, each expression is associated with one field on the user interface. And if we were using pre-coordinated concepts in our list, then the best practice would be to record the concept identifier as the code, and then the term that was displayed or selected by the user as the original text. When post-coordinated expressions are stored, the recommended approach is quite similar. Once again, the display term should be recorded in the health record, but this time the code that is recorded should either be the terse form of the full expression, which is the expression with the terms and spaces removed, or if the size of your codes isn't long enough to allow an expression, then you may choose to store a local expression identifier in your health records. Here is an example of an EHR data store that records the full terse expression in the diagnosis code and the term that was displayed on the user interface in the diagnosis term. To use this approach, the health record must be able to record codes that are as long as the longest expression linked to one of the interface terms. And the codes must also allow non-numeric values to be included, such as the colon and the equal signs that are used in most expressions. Some clinical systems, however, may have limits on the length or data type of the codes that may be recorded in their health records. So in these cases, a unique local identifier can be assigned to each expression so that this shorter expression ID can be stored in the health record in place of the full expression. When local expression identifiers are used, these are then linked to the corresponding full expression and the display term within an expression repository, as you can see in this example. When using the form-based approach for entering post-coordinated expressions, it's usually best to store the data in an information structure that matches the fields on the form, and to record the concept identifier and display term for each of the fields within that information structure. This enables the system to efficiently display health records that have been recorded previously, and also provides full traceability of what the user selected at the point of data entry. You may choose to also store the derived expression in its terse form, generated using your expression template if this is needed for other EHR tasks. Here is an example of the code and term being recorded for each field using the form-based approach. So you don't need to store the full expression in the EHR data store, but it's important to record the data as it was entered by the user. To generate the corresponding expression, an expression template should be used, like this one, with slots or placeholders for each of the values to be entered. In this case, there's a slot for the procedure, the site, and the method. When these values are entered into the corresponding fields on the form, these slots can be populated in the expression template. In this example, the concept ID for surgical procedure replaces the procedure slot in the expression template. The concept ID for appendix replaces the site slot, and the concept ID for excision replaces the method slot. So the concepts that are selected in the user interface are applied to the expression template to form an expression which represents the combined meaning of the selected values. Some implementations may choose to store this derived expression in addition to the individual values of each field to support runtime querying or exchange. And lastly, for the free text approach, you need to store both the free text as it was entered by the user and also the coded expression that was generated by the NLP tool and confirmed by the user. You should also store the terms associated with the expression that were displayed to the user when they confirmed that it accurately reflects the meaning of the free text. Some NLP tools use a library of expression templates, like this one, to find valid expressions that may match the free text. This example template might be used for free text entered into a diagnosis field. As you can see, the template follows the concept model for situations with explicit context and enables values for the associated finding, the finding site, subject relationship, temporal context, and the finding context to be derived from the free text entered by the user. When processing the free text, the NLP algorithm identifies phrases that match Nomencity concepts which are in the valid scope of each template slot, and uses this to replace the slots with relevant Nomencity concepts. When natural language processing is used to assist the coding of clinical information in an electronic health record, and the coded data is used for clinical purposes, it's strongly recommended that the user confirms the automatically generated codes. This is crucial to avoid unintended meanings being derived and stored in the record. In this slide, you see an example of how an NLP tool could display an automatically generated expression on the user interface in a user-friendly way to help the user to confirm that the coded expression correctly reflects the intended meaning. This could be accompanied with the option to change or refine some of the identified concepts. And having confirmed the values, these may be applied to the expression template to generate the associated expression. So having explored how to capture and store expressions, I would now like to continue with introducing different approaches that may be taken to the display of Nomencity expressions. And the first point to make here is that the approach you use to display your expressions will depend on how they are created, stored, and exchanged. But the general recommendation is to display the expressions in the same way as they were entered or confirmed by the user. However, there are exceptions to this, which I will explain shortly. When a post-coordinated expression is created during the implementation process, this will generally involve the manual creation of a display term for each expression. In some cases, the list of clinical phrases will be developed first, based on user requirements, and then these will be mapped to Nomencity expressions. In other cases, a set of post-coordinated expressions will be created first to represent all the clinical meanings that are required, and a display term will need to be created for each expression. In these cases, especially if there is a large number of expressions, the creation of these display terms may be assisted by techniques to automatically suggest appropriate terms for each expression. I will elaborate on this shortly. But first, let's look at the display of expressions where the form-based approach is used. In this case, the advice is to display the expression in the same form as it was entered and approved by the user. With this approach, each of the selected terms are displayed in the same information structure as they were entered, with the labels on each data entry field explaining the purpose of each value. And using the last approach, the free text approach, it's recommended that the system displays the original free text that the user entered, and optionally also the terms associated with the coded expression that the user confirmed. And as shown in this slide, the display of the confirmed expression can be simplified to show the relevant labels and terms of the confirmed values in a concise manner. So far, we've discussed how expressions can be displayed in a way that aligns with how they were created. However, some situations may require expressions to be displayed differently to how they were created. For example, when the expression is created in a different clinical system or a different form on the same system, or it needs to be exchanged using a different information structure. These are all cases in which the information structure used to create the expression may be different to the ones available to display or exchange the expression. So the expression may have been created in a form that uses a diagnosis field and a body side field, and it may need to be displayed or exchanged using a single diagnosis field. In this situation, we don't always have a single term associated with the expression that we can use to display on the target user interface. So even if we can automatically create the expression itself using an expression template, we still need a human readable term to display. And in this situation, methods to assign an auto-generated term for the expression may be considered. Another situation where auto-generated terms may be useful is in systems used to create post-coordinated expressions during the design of an EHR implementation. At design time, an expression could be created using a form-based expression template, and then the system could suggest a display term that captures the meaning of the whole expression. So for these situations in which a new display term is required for a post-coordinated expression, there are a number of techniques that may be applied to auto-generate these. And these techniques range from very simple to more advanced. For example, a simple approach would be to just replace the concept IDs with a term, such as the preferred term in the local dialect. Another approach is to apply simple term rules for specific types of concepts. And finally, dedicated description templates and associated rules may be applied. Consider the following two example expressions. The first expression is an open fracture with a finding site of bone structure of ulna. The second expression is an excision of cyst of lung with a laterality of left. Let's now explore how terms for each of these expressions could be created with each of these approaches. By replacing the concept identifiers with the associated UK preferred terms, you end up with the following readable versions of the expressions. Open fracture, colon, finding site equals bone structure of ulna, and excision of cyst of lung, colon, laterality equals left. In many situations, this simple transform may be adequate to generate an acceptable display term. To improve the generated terms, some additional simple rules may be applied. For example, for any anatomical terms starting with bone structure of, this prefix can be removed. And where there is just a single finding site or a single laterality, the attribute name could be omitted and the attribute value added after a comma. So for these expressions, these additional rules could be used to enhance the term and result in open fracture, comma, ulna, and excision of cyst of lung, comma, left. Finally, description templates and additional rules can be used to further enhance the auto-generated terms, and thus increase the human readability of the display terms associated with each post-coordinated expression. So now I would like to introduce you to the principle of description templates. Suppose that you have an expression template, like the one shown on this slide. This template is used for creating expressions that represent a disorder with a fracture morphology and a finding site of some bone structure. A description template may be associated with this expression template, and this description template specifies that the term associated with the morphology concept is always followed by the term associated with the bone structure concept, and these two terms should be separated by the term of. Associated with this description template is a set of terming rules, and here you see some of the rules that may be specified for the bone structure slot in this template. For example, if you're using the fully specified names, then you must remove the semantic tag. You should also remove the phrase bone structure of if this is present in the term, and remove the term structure if this is contained in the term. Similar rules may be specified for the morphology slot. And let's now consider this expression, which has been created using the expression template here. This expression represents an open fracture of forearm with an associated morphology of fracture open and a finding site of bone structure of ulna. If we use the fully specified names for these concepts, we get the following values for the fracture morphology and bone structure slots. And if we apply these values to the description template with the rules I just showed you, then after removing the semantic tags, removing the phrase bone structure of, and reordering the morphology parts, this leads to an automatically generated human readable term for the expression open fracture of ulna. And here is another example where the value for the fracture morphology is fracture, closed with the semantic tag morphologic abnormality, and the value for the bone structure is structure of distal ulnar epiphysis with the semantic tag of body structure. Again, if we apply these two values to the description template and apply the term transformation rules, we end up with a derived term of closed fracture of distal ulnar epiphysis. So I hope this gives you an idea about how description templates may be an efficient way to automatically create a human readable representation of your expression. To ensure that these auto-generated terms are clinically safe, it's good practice to include a manual review step before using them in a clinical system. And in the next part, I would like to talk to a few principles related to the sharing and exchange of Nomencity expressions. When expressions are used to record clinical data, it's important to establish effective ways of communicating these expressions with other systems. The main options for sharing post-coordinated expressions are to exchange the terse expression as the code of the relevant field with the displayed or auto-generated term, or to decompose the expression into separate fields, one for the focus concept and then one for each of the attribute values in the expression. And then in each field you can simply include the concept identifier as the code and one of the synonyms as the display text. And the last option is to use the expression identifier from your expression repository as the code with the display term. However, it's very important to not share the expression identifier in a health record unless you can guarantee that the receiving system will definitely have access to the same expression repository to find the associated expression that matches the identifier. So this last approach is, in most cases, not recommended. Here you see an example of a fire condition resource, which is used to communicate information about the disorder of a patient. In this example, the resource includes information about a patient who has been diagnosed with a bacterial infection. And you can see that this coded data element is divided into a coding part, which captures the URI for the code system, Nomencity, a URI for the July 2016 International Edition, the pre-coordinated concept ID, and the US preferred term for this concept, bacterial infectious disease. And in the second part, it has a text attribute, which contains the display term that was shown to the user when they selected this concept. So this is how a pre-coordinated concept would be populated in a coded data element in FHIR. And in this next example, you can see how a post-coordinated expression would be populated in the same FHIR resource. In this case, the patient has a fracture of the left tibia. And the main difference is that the code attribute here is populated with the terse form of the post-coordinated expression, fracture of tibia with laterality equals left. If the expression is associated with a published human readable term, or there is a published description template for the expression, then the display value may include that term, as shown here. However, if no term or description template has been published, then the full expression with the terms embedded may be used as the display value. And the text attribute is populated with the term that is displayed to the user in the user interface, in this case fracture of left tibia. Please note that not all receiving systems will be able to interpret a code that contains a post-coordinated expression, so the text attribute is an important mechanism to ensure that the data element can, at a minimum, be human readable. So, now that you have heard about the principles for entering, storing, displaying and exchanging post-coordinated expressions, I would now like to hand back the microphone to Linda for her to introduce you to the principles of querying post-coordinated expressions. So back to you, Linda.
Thanks very much, Anna. So Anna has explained how you can create, display and exchange expressions, and now we're going to dive into the details of how to query expressions, because there's really not a lot of point in going to the effort of using post-coordinated expressions in a health record unless you're able to query them like you can with other Snomed codes. So let's look at what we need to support querying over expressions. Firstly, we need a terminology repository, which contains all of the release concepts, descriptions, and concept definitions. And there are two types of concept definitions, stated and inferred. The stated definitions are represented as description logic AL axioms, and these are the clinical definition that a Snomed author states when they define the meaning of a concept. The inferred definition is then derived or inferred by classifying the stated definitions using a description logic reasoner, and then the output of this classification process is represented using the relationship table in necessary normal form, which basically means that it represents the set of necessary inferred relationships. And it's these inferred definitions that we use when we query over Snomed. So, for example, if we want to find all descendants of a respiratory disorder or every type of infectious disease. If we now add in the expression repository, which holds our post-coordinated expressions, and as we've discussed, this also sometimes includes an expression identifier to provide a local unique reference to each expression, and a display term that can be shown to the user for them to select or understand the meaning of the expression. The expression corresponds to the stated definition of a concept, in that they both represent the logical definition of the clinical meaning as it's stated by the author. And we call these expressions, in the form that they were created, the close to user form expression, because these represent the original intent for the clinical meaning. But just like we can't query directly over the stated concept definitions, similarly, we can't query directly over the close to user form expressions. We need something that's comparable to the inferred concept definitions for querying. And we call this the necessary normal form of the expression, which is similar to the necessary normal form of the concepts, in that it's generated by the description logic classifier. So let's have a look at why we need the necessary normal form of the expression. Suppose we want to query our EHR data store. We have our terminology repository so that we can query the terminology, and our expression repository so that we can query over the expressions. In this example, we have the concepts malignant melanoma of shoulder, and malignant melanoma of chin. And we have two expressions: malignant melanoma with finding site of shoulder region structure with a laterality of left, and malignant melanoma with a finding site equal to shoulder region structure with a laterality of right. So suppose we have a population of patients who whose records are stored in our EHR, and these patients have been diagnosed with one of these conditions. Some people have been diagnosed with a condition represented by a concept, and others have been diagnosed by a condition represented by a post-coordinated expression. So you may want to ask your EHR which patients have a type of malignant melanoma of shoulder, or who has a mass of some body structure, or which patients have a malignant neoplastic disease. And when we ask these questions, we want to make sure that relevant patients are returned by the query whether or not their diagnosis was recorded using a pre-coordinated concept or a post-coordinated expression. So this slide shows a small part of the Nomencity hierarchy with some of the supertypes of malignant melanoma of shoulder. If we consider the question, find all the masses of some body structure, we can quickly identify the pre-coordinated concepts that are descendants or self of massive body structure using an expression constraint query. But how do we work out if these expressions also match our query? The way we do this is by classifying these expressions together with the published concepts to determine where they sit in the hierarchy and what additional inferences we make. And when we do this, we discover that these expressions are in fact a subtype of malignant melanoma of shoulder, and therefore they should be returned in the results of this query together with the relevant concepts. So here is our expression repository again. Once an expression is created and validated against the syntax, the expression should be stored in the same form as it was entered by the user, which, as we said, is called the close to user form. But after the expression is classified, we also need the necessary normal form of the expression to support our queries. But to get from the close to user form to the necessary normal form of the expression, there is often an intermediate step that's required to ensure that the expression conforms to all the concept model rules and is classifiable. And we call this intermediate expression the classifiable form. So let's take a look at each of these forms of an expression. The close to user form expression is the faithful representation of the clinical meaning as it was entered by the user. This is the primary stored and communicated view of the clinical information that's encoded using Nomencity. The close to user form expression includes any refinement that was applied by the system based on the selections made in a data entry form or those made explicitly by the user. And importantly, it does not include any additional relationships that are added based on classifier rules to make the expression complete or to normalize it. It only includes the parts of the clinical meaning that were specifically intended by the user. And before we can classify the expression, we need to transform it into a classifiable form. This classifiable form expression is a syntactically valid and concept model compliant representation of the close to user form expression. It serves as the input to the classifier, enabling expressions to be classified together with other Nomencity content. And in the classifiable form, any ungrouped attributes and role groups have been validated and appropriately applied to the definition of the focus concept. And the third form is the necessary normal form. This is the inferred view of the expression and includes all the relationships that are necessarily true with redundancy removed. So this is the output of the process that took the classifiable form expression and classified it with a given Snomed addition. The necessary normal form represents the necessary relationships used for querying, so this becomes part of your substrate when you're running an expression constraint query. The necessary normal form includes refinements that represent inferred relationships without any redundant refinements or redundant relationship groups. So let's take a look at why we need the classifiable form of an expression. On this slide, you can see 3 different clinical systems which each record the patient has a malignant melanoma of the left shoulder. However, Due to different clinical workflows and different information model design, each system collects this information slightly differently. The first system records a diagnosis of malignant melanoma and a body site of left shoulder. The second records a diagnosis of malignant melanoma and a body site of shoulder with a side or laterality of left. And the third system records a malignant melanoma of shoulder with a side or laterality of left. So the close to user form expression for each of these systems matches the way the data was collected on the user interface, which means that each one of these expressions is different. In this case, it's fairly easy to work out that these three expressions represent the same clinical meaning. But how can the system answer questions about these expressions if they're each represented in a different way? Well, I can tell you that none of these expressions are classifiable as they're currently written, and on the next few slides I'll explain why. Let's look at the first one, malignant melanoma with a finding site equal to left shoulder. Syntactically, this expression is correct because it conforms to the ABNF rules of compositional grammar. And malignant melanoma is in the clinical finding domain, so the attribute finding site is valid to use in this domain, and the attribute value left shoulder is also within the correct range of the attribute, so that complies with the concept model rules as well. However, the concept model states that when you use the finding site attribute, it should always appear inside a role group. But there are no curly braces around the finding site in our expression. So in our close to user form expression, the finding site is ungrouped. And as we mentioned before, the classifiable form needs the role groups to be defined correctly. So to do this, we need to look at the definition of the focus concept malignant melanoma, and you'll see that it contains one role group with an associated morphology. And when we apply this ungrouped finding site from the close to user form to this focus concept, you need to add it into the role group with the associated morphology. So you can see now that the classifiable form still only has one role group, but it now contains both an associated morphology together with the finding site. And by doing this role group transformation, we're helping the classifier to make the correct inferences and therefore place this expression in the correct part of the hierarchy. It's important to note that if we had added the curly braces into the close to user form from the beginning, the expression would have been classifiable, but we would have ended up with two separate role groups, one with an associated morphology and the other with a finding site. And this would not classify in the correct way because we would lose the fact that the malignant melanoma applies to the left shoulder. The next example is fairly similar, but in this case the left shoulder is defined as shoulder with a laterality of left. Once again, this is not classifiable because the finding site is not grouped into a role group. So once again, we look at the definition of the focus concept and apply the finding site with its value to the role group within the definition of malignant melanoma. And here's the third example. This expression is slightly different because it applies the laterality to a clinical finding, and according to the concept model, a laterality should only be applied to an anatomical or acquired body structure. So to transform this expression into a classifiable form, we first need to ensure that it's concept model valid. And to do this, we look at the definition of the focus concept, which in this case is malignant melanoma of shoulder. And we can see that it has one role group with an associated morphology and a finding site. And you'll notice that the finding site of shoulder region structure is a type of anatomical or acquired body structure. And this is in the domain of that laterality attribute. So to transform our close to user form expression into a classifiable form, we need to apply the laterality of left to the value of the finding site from the definition of malignant melanoma of shoulder. And we now have an expression that is both syntactically valid and conforms to the concept model rules. So we're ready to pass this to a description logic reasoner for classification. So we had 3 different close to user forms that transform into 3 different classifiable forms. But we know that the clinical meaning being represented by these 3 expressions is the same. So we would expect the classifier to be able to produce the same necessary normal form for all 3 of these expressions to ensure that we get the same query results irrespective of how the same clinical meaning was originally represented in the close to user form. And very soon we're going to get a demonstration from Kai to show you this transformation and classification process. And hopefully we'll see that these expressions all classify to the same necessary normal form. It's important to be aware that if you transform and classify the close to user form expression against a different version of Nomencity, you may get a different necessary normal form expression. And that's why Anna mentioned earlier that it's important to store the close to user form, because that's the source of truth as to the clinical meaning that the user expressed when they created the expression. So by following this process of creating our expressions in close to user form, transforming them into a classifiable form which conforms to all the concept model rules, and then classifying these expressions with the pre-coordinated content from a particular Snomed release, we're able to run standard expression constraint queries against the necessary normal form representations of both the pre-coordinated and the post-coordinated content in a consistent way. And we can execute the ECL query descendants or self of mass of body structure to find all the types of mass, including both the pre-coordinated concepts and the post-coordinated expressions. Similarly, we can find the descendants or self of malignant melanoma of shoulder and the descendants or self of malignant neoplastic disease. So I'm now going to pass over to Kai, who is going to demonstrate transforming and classifying expressions. Thanks, Kai.
Thank you, Linda. So here we have an implementation that can demonstrate the transformation and classification of post-coordinated expressions. It takes a close to user form in this area. It applies the generic transformation using the machine readable concept model to give the classifiable form. And finally, it classifies and produces the necessary normal form in near real time to be used for semantic querying and data analytics. This user interface is purely for technical demonstration. It's obviously not intended for use by clinicians or other end users. I'm going to work through the 3 expressions that we've been looking at in the slide, and each one will produce the same necessary normal form at the end. So the first close to user form, we've picked a focus concept of malignant melanoma, and we've also applied a finding site of structure of left shoulder. I'm going to click transform, and it's done, and classification is done. So the transformation has taken the focus concept and brought the existing role group from the existing modeling, and then it's looked at the finding site, this loose attribute, and it's found that the MLCM allows this attribute to be applied to this concept, so it's added it to the existing role group. And then the terminology server has classified the expression, and classification has found that there's a new parent available, the malignant melanoma of shoulder. That's the first example done. I'm going to clear and load the second. So here we have the same focus concept, but we are expressing the finding site in a different way. We're giving a value which is a nested expression containing a focus concept of shoulder, which has a laterality of left as an attribute. But that's okay. We click transform again, And a similar thing has happened to the finding site. It is applicable within the MLCM domain of malignant melanoma. So the finding site's been added to the existing role group of the concept. And also the nested expression has been brought over. And the algorithm has checked that laterality can be applied to this focus concept, which is a body structure, so that's okay. This is the classifiable form. Classification has been run, and the necessary normal form produced. And again, we have the same new inferred parent, malignant melanoma of shoulder. We also have a different value for the finding site. So the classification process has found that this expression is subsumed by structure of left shoulder region. So the necessary normal form has been simplified to use the pre-coordinated value here. And that's the second example done. I'm going to clear the form. Last one then. Now this one's a bit different. We've got a different focus concept which expresses that we've got a malignant melanoma of shoulder. This is obviously a disorder. And in the close to user form, we've added a laterality of left. Now, laterality cannot be applied, usually, to a disorder concept. It can only be applied to a body structure. But that's okay. Let's see what the transformation does. So the transformation realizes that the laterality is not within the MLCM domain of the disorder, but it goes and takes the existing role group for the malignant melanoma of shoulder. I'm going to have a quick look at that diagram. So there's an existing role group that has an associated morphology and a finding site of shoulder region structure. And the transformation has added the laterality to the shoulder region structure, because this existing attribute value does have laterality within its MLCM domain, so we can apply the laterality there automatically. This is now a sensible classifiable form, and when we classify, we pick up again the same inferred parent relationship, which was actually what we stated, but we've also again simplified the value of the finding site to have structure of left shoulder region. And that's it. They're the three examples. Okay, back to Linda.
Thanks for the demo, Kai. So we're going to finish off by summarizing the tooling features that need to be available in order to implement expressions. As we've discussed, if you're implementing post-coordination within an EHR system and you want to be able to enter, display, exchange, and query expressions, then your EHR needs an efficient way of performing these tasks seamlessly over both pre-coordinated and post-coordinated content, as if they're interchangeable ways of representing clinical meanings. And the most efficient way of doing this is to use a terminology server that provides a simple API with the services that can query over both the published releases of Nomencity and a repository of expressions as a single classified package or substrate. And it's important that the terminology services are able to perform any of the steps that you require to ensure your expressions are valid, classifiable, and then ready to query. We've talked about the process that's required, which is shown here, from creating your expression, and if you require, also creating a term or an ID for the expression, to validating your expressions, transforming them into classifiable form, classifying them, and then querying the inferred necessary normal form. You can't skip any of these steps if you want to be able to perform these EHR tasks. So to implement post-coordination, you're going to need an EHR system that supports the creation or selection of expressions via a user interface, the ability to either store a full expression in the health record or a local expression identifier that's linked to a full expression via a table or repository of some kind, the exchange of expressions using both the full expression itself with a display term or whatever it was the user selected, and access to terminology services that support the creation of a human readable term for each expression if required, or the ability to store an interface term that's linked to each expression, the creation of a local expression identifier if that's required for storing in the patient records, the syntactic validation of each expression or a guarantee that the expressions are created in a syntactically valid form, the transformation of your close to user form expressions into classifiable ones that conform to all the relevant concept model rules, the classification of your expressions together with a selected Nomencity versioned edition, and then the seamless ability to query over both the pre-coordinated and post-coordinated content together using the expression constraint language. Thanks very much for listening. I hope you've learnt something about post-coordination. We're currently developing a practical guide on how to implement Nomencity post-coordinated expressions. So if you're interested in more details, please look out for an announcement on this in the near future. Could you please now give us one moment while we switch over from our pre-recorded content to our live session so that we can answer any questions you've submitted. And please note that this session will be available on the event platform for the next 3 months. Thank you. Hi, everyone. Thanks for listening. We've got quite a few questions come in during the session, so thank you for that. Anna, Kai and I are going to step through these a couple at a time. Actually, I think the first two are related, but we're all going to give our thoughts on these. So we'll start with Michael's question about, can you explain why modelled concepts need maintenance, but post-coordinated concepts do not, especially in the context of an expression repository, which is very similar, may be confused with pre-coordination. I'm going to answer that in the context also of Marie Alexandra's comment about post-coordinated expressions needing maintenance in a patient record. So from my perspective, both pre-coordinated concepts and post-coordinated expressions both need maintenance, but they need a different type of maintenance. So obviously with pre-coordinated concepts, you need to maintain the logical definitions and the descriptions attached to each of the concepts to make sure that they're still valid. With expressions, they may need to be maintained in the context of either if they're recorded based on an expression template, then you might need to maintain the expression template and ensure that the value sets for each of the slots are current. But one important thing that hopefully we made clear in the tutorial was that the expression that you record in your patient record, the close to user form, should stay unchanged. It should stay as it was recorded by the clinician, even if one of the codes in that expression becomes later inactive down the track. In terms of maintaining that expression, you may, if you're mapping from interface terms to a post-coordinated expression, then you may need to maintain that mapping so that any new expressions recorded will always have active codes in them from the time they're recorded, for example. So you may need to maintain that mapping. You may need to maintain the expression template, and then moving forward, if you need to query against them based on a new edition of Snomed, you may need to perform the transformation again, transforming your close to user form into a classifiable form that can be classified against the new edition. So thank you for those questions. There's quite a bit in that. But Anna and Kai, would you like to add to that answer?
I'll just make a very short comment. The fact that, as Michael writes, that whether post-coordination should not be maintained, and we're not saying that an expression repository does not require maintenance, because of course it does, just as Nomencity in general requires maintenance, as would an expression repository. And I think it's important to also state that part of that maintenance is also ensuring that you do never just go in and delete or update your expressions in your expression repositories, but you need some versioning mechanism so that you have the traceability of your expressions in your expression repository too.
Great point, Anna. Yeah.
I don't have anything else to add to that one. Thank you.
Oh, okay. You can take the next one then, Kai. So, Maria Alexandra, hopefully we've answered your question as well. Certainly in the context of constructing the expression live with an expression template, you're absolutely right. Any new expressions recorded, you'd want to make sure that those value sets that you're using within the expression template use active concepts for any new expressions, but you don't go and change the old ones. You query over those inactive codes. Let's move on to Teresa's question. Would the NRC need to work with suppliers to understand if they can manage post-coordinated expressions, and would this need to be identified at the outset? Did you want to respond to that, Kai?
Yeah, sure. It's not a very easy one to answer. Yes, obviously we're talking about capability in the tooling, so you would need to work with suppliers. Does it need to be identified at the outset? Well, certainly it's possible for tooling that supports post-coordinated expressions to be developed after you've acquired the tooling, but it's probably less likely. So yeah, difficult one to answer.
But I also think that it's about understanding your requirements when you implement Nomencity. What are your requirements in terms of post coordination? Do you need it, or can you meet your requirements using pre-coordinated content only? That would of course be a preference. But if you do have a requirement to support any of the use cases that you have just seen in this session, then one of the things that you would need to discuss with your supplier is what are the services that you need. So what types of requests should your terminology server support? So that definitely needs to be a discussion around those requirements and ensuring that this terminology server meets those requirements.
So you made some really good points there. Firstly, I want to emphasize the fact that if your requirements can be met using pre-coordinated content, then that's the way to go in terms of your maintenance burden, and also just in terms of ease of implementation. But then also, if you do require post-coordinated expressions, it's important to understand what to look for, and the sort of questions you need to ask about the terminology service in terms of which of those functions we talked about does your terminology server provide, and which would you need to implement as a separate part before you pass your expressions to your terminology server. So
it's probably also relevant to mention that having a mixture of coding, against pre-coordinated and post-coordinated expressions is okay. So if you started, capturing data in your MLC using pre-coordinated, then post-coordinated could be added later. There's no problem.
That's true. Vadim asked, how can one check a post-coordinated expression to see if it's classifier valid? And I see Michael gave an answer, which we agree with. So to test whether a post-coordinated expression is classifier valid, it's important to check it against, well, firstly, it needs to be syntactically valid. So you test it against your compositional grammar ABNF. And to be classifier valid, it also needs to conform to the MRCM rules. And you can find the MRCM rules in the reference sets of the International Edition. Anna or Kai, did you want to add anything to that?
No.
Michael suggests running it through, a transformation to see if it changes. If the expression only contains grouped attributes, then we can expect no change. If there's some that are ungrouped, then yeah, maybe the transformation will do something to make it more classifiable.
Thanks, Kai. Valentin says, what are the risks for interoperability of working with post-coordinated expressions, and might specific value sets be a more inclusive alternative? Yeah, that's a really good point. When you're exchanging post-coordinated expressions, there's obviously a risk that the receiving system can't interpret those or do data analytics over those expressions. So that's one of the reasons why it's important to always have the original text or the representation that the clinician sees, so at least they can be human readable at the receiving end. And then if the receiving end also is able to computer process them, then that's just an added bonus, but you must exchange that human readable representation as well. Anna or Kai, any other thoughts?
My only thought here is that when you get to a point where expressions may be distributed widely and exchanged, and there comes a time when it's also you need to consider whether should this expression actually be requested for being part of an extension or even the international edition, and that's the balance between authoring pre-coordinated concept for an extension or the international edition and applying post-coordination. So you always need to have that awareness of, is this situation a good case for post-coordination, or is it something that we need to consider requesting for addition to Nomencity?
Good point, Anna. And I'm going to pass this question to you, Kai. It's another one from Vadim, which says, is there a tool to check this, which is whether an expression is in classifiable form, or at least run my post-coordinate expression against? He was using AutoServer's validate code to see if my post-coordinate expression was syntactically valid, but would also like to see if a classifier will be happy with it. So any comments from a snowstorm perspective, Kai?
Yeah, so we have been working and building this capability into Snowstorm, both the validation of a closed user form, both syntactically against the MRCM, as you saw in the demo. The demo was purely driven by the Snowstorm API, which is in development. I can't give you a timeline, but yeah, that will be available sometime next year, I think. So. If you need a quicker turnaround, you're welcome to come and speak to me. If you want help generating your own parser from the ABNF or anything like that.
Thanks, Kai, and thanks for the question, Vadim. And thank you to everyone for the lovely comments. And I see Ian asked, are there any tools available to do the transform? And I think Kai's previous answer spoke to that. Do you have anything to add, Kai? No? Great. Prabhat has asked, we're working on Snomed auto-coding engine. Must we query the EMR, EHR vendor if they have the expression repository so that we can generate the pluggable data from a clinical free text? Well, that depends on what your solution is and whether you want to run natural language processing to produce pre-coordinated concept matches, in which case you would need to consider the context-related data using a set of pre-coordinated codes, or if you did want to generate expressions, if you need to run data analytics over your expressions, then you will need to find out whether your engine is able to classify those expressions, because that's the only way that you can then safely query over those.
Yeah.
Anything to add, Anna or Kai?
No, I have nothing to add there.
Just reiterating that post-coordinated expressions do need classifying before running queries and data analytics.
Mm.
I hope that answered your question, Prabhat. Just reading through the questions. You're welcome, Marie Alexandra. And Prabhat asked, what are the minimum common ground must we have as a Snomed auto-coding engine with the EMR, EHR vendor so that we could work easily, seamlessly? I suggest you come and have a chat with us, Prabhat, so that we can understand your use case a bit better. I think there's probably a bit of context and background to that, but we'd love to have a chat with you and help you out by better understanding your requirements.
But in that last slide, Linda showed those bullet points there is really trying to pull out the main points about what you need in order to be able to process post-coordinated expressions. So as a starting point, I would point you back to that last slide where she made that summary of requirements.
Thanks, Anna. And if you are converting free text to Snomed and using post-coordinated expressions as part of that, then you may not need to classify in the natural language processing, but then to query subsequently over the post-coordinated expressions that are generated at that stage, you would need all of those requirements that I listed previously in that last slide, as Anna mentioned. Anything else, Anna or Kai?
We have covered all the questions that have come in, so I think we should just leave a few moments to see if more questions come in.
Brian has just asked, how much of the tooling behind the demonstrations we saw today is available on GitHub? Kai?
It's all available, but it's not fully tested. It's in developed branches. There's specific branches in the Snomed toolkit and the Snowstorm, repositories. All the code's checked in. So yeah, get in touch if you want to play with it. But yeah, as I said, it's in development.
Hopefully we'll have more for you very soon, Brian. And Vadim has asked, how do you see industry adoption of post-coordinated expressions, and could anything be done to help improve it? From my perspective, it's all about tooling. To do post-coordination properly, you need the tooling in place, and we're working as hard as we can to get that tooling in place, but there are also commercial vendors out there who have terminology services that can support classification of expressions. So tooling.
Yeah.
Anything else to add to that, Anna and Kai?
Tooling.
Thanks, Anna. Okay, wonderful. Thank you so much for your lovely comments, everyone. If you have any other questions, please feel free to come and find us during the conference in the meeting hub or afterwards. We're all available and we'd love to continue this discussion after the session. So thank you so much for your time. Appreciate you joining us, and I hope you enjoy the rest of the Expo. Thank you.
Bye, everyone.